Good evening, friends, and welcome to Sleepytimetales, a podcast aimed at helping you to get a good night's sleep. Do you find your mind plagued with the stresses of modern life, especially when the lights are out and you're trying to get a restful night? Does your spinning mind keep you awake? Follow my voice down the path towards a good night's rest. Listen to me tell a story that will keep your mind from wandering to your daytime problems, the ones you can't solve right now and will be easier to solve while rested. Listen to my voice and allow yourself to drift, following the twists and turns of the story, but slowly letting go and drifting into sleep. Before we get on with the show, I'd like to ask for a couple of minutes of your time. While in most episodes this is the chance I take to talk about the Patreon and the buy me a coffee and the tip jar to help me cover the costs of the show, I'm focusing this month on something a little bit different. Because while money is handy, it is after all how we buy things and how I pay for the services that I use for this podcast. The real engine of any medium, whether podcast or TV show or book, is the people who love it talking about it. So this is my appeal to you tonight. A lot of people are struggling to sleep these days, and I'd like you to spread the word. If there are people in your life who struggle to sleep, just try telling them about Sleepytimetales. There may even be people who you will need to teach how to listen to a podcast because it may sound strange to anyone who listens to it. There are a lot out there who don't. So if you're a podcast listener and someone you know isn't, you may be introducing them to a whole new world, even outside of this weird little project of mine. And importantly, if you share on social media, please make sure to mention me at Sleepytimetales on Instagram or Twitter so that I can thank you and I can shout you out here. And while I don't make Facebook much of a priority, I've got to thank Tanya for spreading the word, who had some very kind things to say on Facebook and shared it with her followers and friends. So thank you very much, Tanya, for that. And that sort of thing is really important and really helpful, because I don't advertise the show. I'm not sure how I could actually effectively and economically advertise it. So you spreading the word is what I depend on. And of course, I did mention up front, and I'm going to mention again, although no, it's not a big priority this week, is if you would like to give some financial support to the show, take a look in the show notes and take a look at the Patreon, where you can sign up monthly to get some pretty cool bonuses. Or you can throw once-off little tips into the Buy Me a Coffee or the PayPal tip jar on the website. So those are options there as well. And finally, and absolutely not the least, I've got to shout out the music, which is Sweet Night and Friends by Kumiku. Their music is available on their website at loyaltyfreakmusic.com. I've linked the website in the show notes because they've got some very cool stuff that they release under various names that I recommend checking out. And thanks for taking the time. Let's get back to the show. So what exactly is Sleepytimetales? What is it for? What is this strange thing, this podcast that you're supposed to fall asleep to? Lack of sleep is a health crisis in the 21st century, and this is a podcast intended to help those that it can to get a restful night. Do you find yourself lying awake at night, mind spinning and emotions in turmoil with anxieties of 21st century life? Do you wake up in the middle of the night and find yourself not quite able to doze back off at 3 a.m.? Well, I'm here to help. My name is Dave, and I'm your narrator, here to help you into a restful night. Sleepytimetales is intended to be used as a distraction to what keeps you awake at night, or maybe sometimes background noise or company. That's why I make the episodes quite long, so that I'm here for you without any pressure of the end coming. There are a couple of different ways that I know of to engage with the show. The primary idea is that it gives you something to focus on, a story or an event that lets you keep your mind on a specific point, to stop it from spinning out into stress and anxieties, to focus just enough not to resist the embrace of a night's sleep when it comes for you. But maybe some people have different needs. Maybe you just need some kind of background noise. People like ASMR or white noise or the sound of the rain or sound of the wind in the trees, or maybe some boring dude just droning on in the background is what is going to help you. But the main thing is that you don't try force to sleep. Just keep a light mental grip on the thread of the story and allow sleep to come for you. Now obviously I hope that you're asleep before I get to the end of the episode, but it is important not to feel pressurized. It may not work on your first night. Maybe it will take a few nights for you to get used to listening to my voice. Maybe my accent is strange to you. Maybe one episode just isn't long enough, at least early on. Or maybe your problem isn't so much going to sleep. Maybe you struggle by waking up in the middle of the night. What I recommend is downloading a few episodes of the show, maybe enough to run through the whole night, and then just pop your earbuds in and let them play. Then if you wake up at 3 a.m. or some other time, you can just pop them back in and go back to sleep again. I even recommend you try that if you wake up a little bit before the alarm, 30 minutes or 60 minutes before you're due to wake up. And it may sound strange to you, what seems to be the point in the extra 30 minutes of sleep. But I've had people actually thank me for making this suggestion, because there is something about allowing yourself perfect relaxation right before the alarm that is satisfying on a whole new level. But it is very important that you try to relax. If you're new to the show and prone to late nights lying staring at the ceiling, this may seem strange to you, so give it a chance. Because I'm here to work with you, to create a safe space, a cocoon in which you can curl up and allow nature to take its course. So if you're still with me, thank you for staying. If you're already asleep, we'll chat again soon. And of course, you aren't hearing me, except maybe in a dream. Astronomy, The Science of the Heavenly Bodies, by David Todd, Director Emeritus, Amherst College Observatory. Published New York and London by Harper & Brothers, 1922. Preface. Sir William Rowan Hamilton, the eminent mathematician of Dublin, has, of all writers ancient and modern, most fittingly characterized the ideal science of astronomy as man's golden chain connecting the heavens to the earth, by which we learn the language and interpret the oracles of the universe. The oldest of the sciences, astronomy is also the broadest in its relations to human knowledge and the interests of mankind. Many are the cognate sciences upon which the noble structure of astronomy has been erected, foremost of all geometry and the higher mathematics, which tell us of motions, magnitudes, and distances, physics and chemistry, of the origin, nature, and destinies of planets, sun and star, meteorology, of the circulation of their atmospheres, geology, of the structure of the moon's surface, mineralogy, of the constitution of meteorites. While if we attack, even elementally, the fascinating, though perhaps forever unsolvable problem of life in other worlds, the astronomer must invoke all the resources that his fellow biologists and the many-sided science can afford him. The progress of astronomy from age to age has been far from uniform, rather by leaps and bounds, from the earliest epoch when man's planet Earth was the center about which the stupendous cosmos wheeled, for whom it was created, and for whose edification it was maintained, down to the modern age whose discoveries have ascertained that even our stellar universe, the vast region of the solar domain, is but one of the thousand of island universes that tenant the inconceivable immensities of space. Such results have been attainable only through the successful construction and operation of monster telescopes that bring to the eye and visualize on photographic plates the faintest of celestial bodies, which were the despair of astronomers only a few years ago. But the end is not yet. Astronomy today is but passing from infancy to youth. And with new and greater telescopes, with new photographic processes of higher sensitivity, with the help of modern invention in overcoming the obstacle of the air, the constant foe of the astronomer, who will presume to set down any limit to the leaps and bounds of astronomy in the future? So rapid indeed has been the progress of astronomy in very recent years, that the present is especially favorable for setting forth its salient features, and this book is an attempt to present the wide range of astronomy in readable fashion, as of a story with a definite plot, from its origin with the shepherds of ancient Chaldea, down to present-day ascertainment of the actual scale of the universe, and definite measures of the huge volume of supersolar giants among the stars. David Todd, Amherst College Observatory, November 1921. Chapter 1. Astronomy a Living Science. Like life itself, we do not know when astronomy began. We cannot conceive a time when it was not. Man of the early Stone Age must have begun to observe sun and moon and stars, because all the bodies of the cosmos were there, then as now. With his intellectual birth, astronomy was born. Onward through the childhood of the race, he began to think on the things he observed, to make crude records of times and seasons. The Chaldeans and Chinese began each to their own system of astronomy. The causes of things and the reasons underlying phenomena began to attract attention, and astronomy was cultivated not for its own sake, but because of its practical utility in supplying the data necessary to accurate astrological prediction. Belief in astrology was universal. The earth set in the midst of the wonders of the sky was the reason for it all. Clearly the earth was created for humanity. So too the heavens were created for the edification of the race. All was subservient to man. Naturally, all was geocentric or earth-centered. From the savage who could count only to 5, the digits of one hand, civilized man very slowly began to evolve. He noted the progress of the seasons. The old records of eclipses showed Thales, in early Greek, how to predict their happenings, and true science had its birth when man acquired the power to make forecasts that always came true. Few ancient philosophers were greater than Pythagoras, and his conceptions of the order of the heavens and the shape and motion of the earth were so near the truth that we sometimes wonder how they could have been rejected for 20 centuries. We must remember, however, that man had not yet learned the art of measuring things, and the world could not be brought into subjection to him until he had. To measure he must have tools, instruments. To have instruments he must learn the art of working in metals, and all this took time. It was a slow and in large part imperceptible process. It is not yet finished. The earliest really sturdy manifestation of astronomical life came with the birth of Greek science, culminating with Aristarchus, Hipparchus, and Ptolemy. The last of these great philosophers, realizing that only the art of writing prevents man's knowledge from perishing with him, set down all the astronomical knowledge of that day in one of the 3 greatest books on astronomy ever written, the Almagest, a name for it derived through the Arabic, and really meaning the greatest. The system of earth and heaven seemed as if finished, and the authority of Ptolemy and his Almagest were as holy writ for the unfortunate centuries that followed him. With fatal persistence, the fundamental error of his system delayed the evolutionary life of science through all that period. But man had begun to measure. Geometry had been born, and Eratosthenes had indeed measured the size of the earth. Tools in bronze and iron were fashioned closely after the models of tools of stone, astrolabes and armillary spheres were first built on geometric spheres and circles, and science was then laid away for the slumber of the Dark Ages. Nevertheless, though all this dreary period the life of the youthful astronomical giant was maintained, time went on, the heavens revolved, sun and moon and stars kept their appointed places, and Arab and Moya and the monarchs of the East were there to observe and record, even if the world mind was lying fallow, and no genius had been born to inspire anew that direction of human intellect on which the later growth of science and civilization depends. With the growth of the collected mind of mankind, from generation to generation, we note that ordered sequence of events which characterizes the development of astronomy, from earliest peoples down to the age of Newton, Herschel, and the present. It is the unfolding of a story as if with a definite plot from the beginning. Leaving to philosophical writers the great fundamental reason underlying the intellectual lethargy of the Dark Ages, we only note that astronomy and its development suffered with every other department of human activity that concerned the intellectual progress of the race. To knowledge of every sort the medieval spirit was hostile, but with the founding and growth of universities a new era began. The time was ripe for Copernicus and a new system of the heavens. The discovery of the New World and the revival of learning through the universities added that stimulus and inspiration which marked the transition from the Middle Ages to our modern era, and the life of astronomy, long dormant, was quickened to an extraordinary development. It fell to the lot of Copernicus to write the second great book on astronomy, De Revolutionibus Omnibus Celestium. But the new heliocentric or sun-centered system of Copernicus, while it was the true system bidding fair to replace the false, could not be firmly established except on the basis of accurate observation. How fortunate was the occurrence of the new star of 1572 that turned the keen intellect of Tycho Brahe towards the heavens. Without the observational labors of Tycho's lifetime, what would the mathematical genius of Kepler have availed in discovery of his laws of motion of the planets? Historians dwell on the destruction and violent conflicts of certain centuries of the Middle Ages, quite overlooking the constructive work in progress through the entire era. Much of this was of a nature absolutely essential to the new life that was to manifest itself in astronomy. The Arabs had made important improvements in mathematical processes. European artisans had made great advances in the manufacture of glass and in the tools for working in metals. Then came Galileo with his telescope, revealing anew the universe to mankind. It was the north of Italy where the Renaissance was most potent, recalling the vigorous life of ancient Greece. Copernicus had studied here. It was the home of Galileo. Columbus was a Genoese, and the compass which guided him to the Western world was a product of deft Italian artisans, whose skill with that of their successors was now available to construct the instruments necessary for further progress in the accurate science of astronomical observation. Even before Copernicus, Johann Müller, better known as Regiomontanus, had imbibed the learning of the Greeks while studying in Italy, and founded an observatory and issued nautical almanacs from Nuremberg, the basis of those by which Columbus was guided over untraversed seas. About this time, too, the art of printing was invented, and the interrelation of all the movements then in progress led up to a general awakening of the mind of man, and eventually an outburst in science and learning, which has continued to the present day. Naturally, it put new life into astronomy, and led directly up from Galileo and his experimental philosophy to Newton and the Principia, the third in the trinity of great astronomical books for all time. To get to the bottom of things, one must study intimately the history of the intellectual development of Europe through the 15th and 16th centuries. Many of the Western countries were ruled by sovereigns of extraordinary vigor and force of character, and their activities tended strongly towards that firm basis on which the foundations of modern civilization were securely laid. Contemporaneously with this era, and following on through the 17th century, came the measurements of the Earth by French geodesists, the construction of greater and greater telescopes, and the wonderful discoveries with them by Huygens, Cassini, and many others. Most important of all was the application of telescopes to the instruments with which angles are measured. Then, for the first time, man had begun to find out that by accurate measurements of the heavenly bodies, their places among the stars, their sizes and distances, he could attain to complete knowledge of them and so conquer the universe. But he soon realized the insufficiency of the mathematical tools with which he worked, how unsuited they were to the solution of the problem of three bodies, sun, earth, and moon, under the Newtonian law of gravitation, let alone the problem of n bodies, mutually attracting each other, and every one perturbing the motion of every other one. So the invention of new mathematical tools was prosecuted by Newton and his rival Leibniz, who, by the way, showed himself as great a man as a mathematician. Taking mathematics, wrote Leibniz, from the beginning of the world to the times when Newton lived, what he had done was much the better half. Newton was the greatest of astronomers, who, since the revival of learning, had observed the motions of the heavenly bodies and sought to find out why they moved. Copernicus, Tycho Brahe, Galileo, Kepler, Newton, all are bound together as in a plot. Not one of them can be dissociated from the greatest of all discoveries. But Newton, the greatest of them all, revealed his greatness even more by saying, "If I have seen further than other men, it is because I have been standing on the shoulders of giants." Elsewhere he says, "All this was in the 2 plague years of 1665 and 1666. He was then but 24. For in those days I was in the prime of my age for invention, and minded mathematics and philosophy more than at any time since." All school children know these as the years of the plague and fire, but very few, in school or out, connect these years with 2 other far-reaching events in the world's history: the invention of the infinitesimal calculus and the discovery of the law of gravitation. We have passed over the name of Descartes, almost contemporary with Galileo, founder of modern dynamics, but his initiation of one of the greatest improvements of mathematical method cannot be overlooked. This era was the beginning of the Golden Age, of mathematics that embraced the lives of the versatile Euler, equally at home in dynamics and optics and lunar theory, of Lagrange, author of the elegant Mécanique analytique, and Laplace, of the unparalleled Mécanique céleste. With them and a fully elaborated calculus, Newton's universal law had been extended to all the motions of the cosmos. Even the tides and precession of the equinoxes, and Bradley's nutation were accounted for and explained. Mathematical or gravitational astronomy had attained its pinnacle. It seemed to be a finished science. All who were to come after must be but followers. The culmination of one great period, however, proved to be but the inception of another epoch in the development of the living science. The greatest observer of all time, with a telescope built by his own hands, had discovered a great planet far beyond the then confines of the solar system. Mathematicians would take care of Uranus, and Herschel was left free to build bigger telescopes still, and study the construction of the stellar universe. Down to his day, astronomy had dealt almost wholly with the positions and motions of the celestial bodies. Astronomy was a science of where. To inquire what the heavenly bodies are, seemed to Herschel worthy of his keenest attention also. While a knowledge of the construction of the heavens has always been the ultimate object of my observations, as he said, and his ingenious method of stargazing was the first practicable attempt to investigate the construction of the sidereal universe, he nevertheless devoted much time to the description of nebulae and their nature, as well as their distribution in space. He was the founder of double-star astronomy, and his researches on the light of the stars by the simple method of sequences were the inception of the vast fields of stellar photometry and variable stars. The physics of the sun also was by no means neglected, and his life work earned for him the title of Father of Descriptive Astronomy. While progress and discovery in the earlier fields of astronomy were going on, the initial discoveries in the vast group of small planets were made at the beginning of the 19th century. The great Bessel added new life to the science by revolutionizing the methods and instruments of accurate observation, his work culminating in the measure of distance of 61 Cygni, first of all the stars whose distance from the Sun became known. Wonderful as was this achievement, however, a greater marvel still was announced just before the middle of the century. A new planet, far beyond Uranus, whose discovery was made as a direct result of mathematical researches by Adams and Leverrier, and affording an extraordinary verification of the great Newtonian law. These were the days of great discoveries, and about this time the giant of all the astronomical tools of the century was erected by Lord Rosse, the Leviathan reflector, with a speculum 6 feet in diameter, which remained for more than half a century the greatest telescope in the world, and whose epochal discovery of spiral nebulae has as greater significance than we yet know, or perhaps even surmise. The living science was now at the height of a vigorous development, when a revolutionary discovery was announced by Kirchhoff, which had been hanging fire nearly half a century. The half-century, too, which had witnessed the invention of photography, the steam engine, the railroad, and the telegraph. 3 simple laws by which the dark absorption lines of a spectrum are interpreted, and the physical and chemical constitution of sun and stars ascertained, no matter what their distance from us. Huggins in England and Secchi in Italy were quick to apply the discovery to the stars, and Draper and Pickering by masterly organization have photographed and classified the spectra of many 100,000 stars of both hemispheres, a research of the highest importance which has proved of unique service in studies of stellar movements, and the structure of the universe by Eddington and Shapley, Campbell and Kapteyn, with many others who are still engaged in pushing our knowledge far beyond the former confines of the universe. Few are the branches of astronomy that have not been modified by photography and the spectroscope. It has become a measuring tool of the first order of accuracy, measuring the speed of stars and nebulae towards and from us, measuring the rotational speed of sun and planets, corona and Saturnian ring, measuring the distances of whole classes of stars from the solar system, measuring afresh even the distance of the sun, the yardstick of our immediate universe, measuring the drift of the sun with his entire family of planets 12 miles every second in the direction of Alpha Lyrae, and discovering and measuring the speed of binary suns too close together for our telescopes, and so making real the astronomy of the invisible. Impatient of the handicap of a turbulent atmosphere, the living science has sought out mountain tops, and there erected telescopes vastly greater than the Leviathan of a past century. There the sun in every detail of disk and spectrum is photographed by day, and stars with their spectra and nebulae by night. Great streams of stars are discovered and the speed and direction of their drift ascertained. The marvels of the spiral nebulae are unfolded, the multitudinous forms portrayed and deciphered. And their distances? And the distances of the still more wonderful clusters? far, inconceivably far beyond the Milky Way. And are they island universes? And can man, the measurer, measure the distance of the mainland beyond? Chapter 2. The First Astronomers. Who were the first astronomers? And who wrote the first treatise on astronomy, oldest of the sciences? Questions not easy to answer in our day. With the progress of archaeological research or inquiry into the civilization and monuments of early peoples, it becomes certain that man has lived on this planet Earth for tens of thousands of years in the past, as an intelligent, observing, intellectual being, and it is impossible to assign any time so remote that he did not observe and philosophize upon the firmament above. We can hardly imagine a people so primitive that they would fail to regard the sun as the lord of the day, and therefore all-important in the scheme of things terrestrial. Says Anne Bradstreet of the sun in her Contemplations, "What glories like to thee, soul of this world, this universe is I, no wonder some made thee deity." To the Babylonians belongs the credit of the oldest known work on astronomy. It was written nearly 6,000 years ago, about BC 3800, by their monarch, Sargon I, king of Gad. Only the merest fragments of this historic treatise have survived, and they indicate the reverence of the Babylonians for the sun. Another work by Sargon is entitled Omens, which shows the intimate relationship of astronomy to mysticism and superstitious worship at this early date, and which persists even at the present day. As remotely as BC 3000, the sun god Shamash and his wife Aya are carved upon the historic cylinders of hematite and lapis lazuli, and one of the oldest designs on these cylinders represents the sun god coming out of the door of sunrise, while a porter is opening the gate of the east. The Semitic religion had as its basis a reverence for the bodies of the sky, and Samson, Hebrew for sun, was probably the sun god of the Hebrews. The Phoenician deity Baal was a sun god under differing designations, and at the epoch of the Shepherd Kings, about BC 1500, during the Hyksos dynasty, the sun god was represented by a circle or disk with extended rays ending in hands, possibly the precursor of the frequently recurring Egyptian design of the winged disk or winged solar globe. Hittites, Persians, and Assyrians, as well as the Phoenicians, frequently represented the sun god in similar fashion in their sacred glyphs or carvings. For a long period in early human history, astronomy and astrology were pretty much the same. We can trace the history of astrology back as far as BC 3000 in ancient Babylonia. The motions of the sun, moon, and the 5 lucid planets of that time indicated the activity of the various gods who influenced human affairs. So the Babylonian priests devised an elaborate system of interpreting the phenomena of the heavens, and attaching the proper significance in human terms to everything that took place in the sky. In Babylonia and Assyria, it was the king and his people for whom the prognostications were made out. It was the same in Egypt. Later, about the 5th century BC, astrology spread through Greece, where astrologers developed the idea of the influence of planets upon individual concerns. Astrology persisted through the Dark Ages, and the great astronomers Copernicus, Tycho, Kepler, Gassendi, and Huygens were all astrologers as well. Milton makes many references to planetary influence. Our language has many words and direct origin in astrology, and in our great cities today are many astrologers who prepare individual horoscopes for more than ordinary interest. It is difficult to assign the antiquity of the Chinese astronomy with any approach to definiteness. Their earliest records appear to have been total eclipses of the sun, going back nearly 2,200 years before the Christian era and nearly 1,000 years earlier the Hindu astronomy sets down a conjunction of all the planets, concerning which, however, there is doubt whether it was actually observed or merely calculated backward. Owing to a colossal misfortune, the burning of all native scientific books by order of the Emperor Xin Huangti in BC 221, excepting only the volumes related to agriculture, medicine, and astrology. The Chinese lost a precious mass of astronomical learning accumulated through the ages. No less an authority than Wells Williams credits them with observing 600 solar eclipses between BC 2159 and AD 1223. And there must have been some centuries of eclipses observed and recorded anterior to BC 2159, as this is the date assigned to the eclipse which came unheralded by the astronomers royal, He and Ho, who had become intoxicated and forgot to warn the court, in accord with their duty. China was thereby exposed to the anger of the gods, and He and Ho were executed by His Majesty's command. It is doubtful if there was an earlier record of any celestial phenomenon. Chapter 3. Pyramid, Tomb and Temple. Inquiry into the beginnings of astronomy in ancient Egypt reveals most interesting relations of the origins of the science to the life and work and worship of the people. Their astronomers were called the mystery teachers of heaven. Their monuments indicate a civilization more or less advanced, and their temples were built on astronomical principles and dedicated to purpose of worship. The Egyptian records carry us back many thousands of years, and we find that in Egypt, as in other early civilizations, observation of the heavenly bodies may be embraced in three pretty distinct stages. Awe, fear, wonder, and worship were the first. Then came utility. A calendar was necessary to tell men when to plough and sow and reap and mow, and a calendar necessitated astronomical observations of some sort. Following this, the third direction required observations of celestial positions and phenomena, also because astrology, in which the potentates of every ancient realm believed, could only thrive as it was based on astronomy. Sun worship was preeminent in early Egypt as in India, where the primal antithesis between night and day struck terror in the unformed mind of man. In one of the Vedas occurs this significant song to the god of day. Will the sun rise again? Will our old friend the dawn come back again? Will the power of darkness be conquered by the god of light? Quite different from India, however, is Egypt in matters of record. In India, records in papyrus, but no monuments of very great antiquity. In Egypt, no papyrus, but monuments of exceeding antiquity and abundance. Herodotus and Pliny have told us of the great antiquity of these monuments, even in their own day. And research by archaeologist and astronomer has made it certain that the pyramids were built by a race possessing great knowledge of astronomy. The temples, too, were constructed in strict relation to stars. Not only are the temples, as Edfu and Dendera, of exceeding interest in themselves, but associated with them are often huge monoliths of syenite, obelisks of many hundred tons in weight, which the astronomer recognizes as having served as observation pillars or gnomons. Specimens of these have wandered as far from home as Central Park and the bank of the Thames. But there is an even more remarkable wealth of temple inscriptions, zodiacs especially. Next to the sun himself was the worship of dawn and sunrise, the great revelations of nature. There were numerous hymns to the still more numerous sun gods and the powers of sunlight. Ra was the sun god in his noontide strength, Osiris the dying sun of sunset. Only two gods were associated with the moon, and for the stars a special goddess, Sesheta. Sacrifices were made at daybreak, and the stars that heralded the dawn were the subjects of careful observation by the sacrificial priests, who must therefore have possessed a good knowledge of star places and names, doubtless in belts of stars extending clear around the heavens. Those decans, as they were called, are the exact counterparts of the moon stations devised by the Arabians, Indians, and other peoples for a like purpose. The plane or circle of observation, both in Egypt and India, was always the horizon, whether the sun was observed, or moon or stars. So the sun was often worshipped by the ancient Egyptians as the lord of two horizons. It is sometimes difficult to keep in mind the fact, in regard to all the temples of the ancients, whether in Egypt or elsewhere, that in studying them we must deal with the risings or settings of the heavenly bodies in quite different fashion from that of the astronomer of today, who is mainly concerned only with observing them on the meridian. The axis of the temple shows by its direction the place of rising or setting. If the temple faces directly east or west, its amplitude is 0. Now the sun, moon, and planets are, as everyone knows, very erratic as to their amplitudes, i.e. horizon points of rising and setting. So it must have been the stars that engrossed the attention of the earliest builders of temples. After that, temples were directed to the rising sun at the equinox or solstices. Then came the necessity of finding out about the inclination or obliquity of the ecliptic, and this is where the gnomon was employed. At Karnak are many temples of the solstitial order. The wonderful temple of Amun-Ra is so oriented that its axis stands in amplitude 26 degrees north of west, which is the exact amplitude of the sun at Thebes, at sunset of the summer solstice. The axis of a lesser temple adjacent points to 26 degrees south of east, which is the exact amplitude of sunrise at the winter solstice. At Giza we find the temples oriented, not solstitially, but by the equinoxes. That is, they faced due east and west. People who worship the sun at the solstice must have begun their year at the solstice, and Sir Norman Lockyer shows how the rise of the Nile, which took place at the summer solstice, dominated not only the industry, but the astronomy and religion of Egypt. Looking into the question of temple orientation in other countries, as China for example, Lockyer finds that the most important temple of that country, the Temple of the Sun at Peking, is oriented to the winter solstice. And Stonehenge, as has long been known, is oriented to sunrise at the summer solstice. In like fashion, the rising and setting of many stars were utilized by the Egyptians, in both temple and pyramid, and no astronomer who has ever seen these ancient structures and studied their orientations can doubt that they were built by astronomers for use by astronomers of that day. The priests were the astronomers, and the temples had a deep religious significance, with a ceremony of exceeding magnificence, wherever observations of heavenly bodies were undertaken, whether of sun or stars. Hindu and Persian astronomy must be passed over very briefly. Interesting as their systems are historically, there were few, if any, original contributions of importance, as the Indian treatises bear strong evidence of Greek origin. Chapter 4. Origin of Greek Astronomy. While the Greeks laid the foundation of modern scientific astronomy, they were not as a whole observers, rather philosophers, we should say. The latter representatives of the Greek school, however, saw the necessity of observation as a basis of true induction, and they discovered that real progress was not possible unless their speculative ideas were sufficiently developed and made definite by the aid of geometry, so that they became capable of detailed comparison with observation. This was the necessary and ultimate test with them, and the same is true today. The early Greek philosophers were, however, mainly interested not in observations, but in guessing the causes of phenomena. Thales of Miletus, founder of the Ionian school, introduced the system of Egyptian astronomy into Greece about the end of the 7th century BC. He is universally known as the first astronomer who ever predicted a total eclipse of the sun that happened when he said it would. The eclipse of BC 585. This he did by the means of the Chaldean eclipse cycle of 18 years, known as the Saros. Aristarchus of Samos was the first and most eminent of the Alexandrian astronomers, and his treatise on the magnitudes and distances of the sun and moon is still extant. The method of ascertaining how many times further the sun is than the moon is very simple and geometrically exact. Unfortunately, it is impossible, even today, to observe with accuracy the precise time when the moon quarters, an observation essential to this method, because the moon's terminal, or line between day and night, is not a straight line as required by theory, but a jagged one. By his observation, the sun was only 20 times further away than the moon, a distance which we know to be nearly 20 times too small. His views regarding other astronomical questions were right, although they found little favor among contemporaries. Not only was the Earth spherical, he said, but it rotated on its axis, and also traveled around the sun. Aristarchus was indeed the true originator of the modern doctrine of motions in the solar system, and not Copernicus, 17 centuries later. But Seleucus appears to have been his only follower in those very advanced conceptions. Aristarchus made out the apparent diameters of the sun and moon as practically equal to one another, and inferred correctly that their real diameters are in proportion to their distances from the Earth. Also, he estimated from observations during an eclipse of the moon that the moon's diameter is about 1/3 that of the Earth. Aristarchus appears to have been one of the cleverest and most accurate thinkers among the ancient astronomers. Even his views concerning the distances of the stars were in accord with the fact that they were measurably distant, as compared with the distances of the sun, moon, and planets. Practically contemporary with Aristarchus were Timocharis and Aristillus, who were excellent observers, and left records of position of sun and planets, which were exceedingly useful to their successors. Hipparchus and Ptolemy in particular. Indeed, their observation of star positions was such that, in a way, they deserve the fame of having made the first catalogue, rather than Hipparchus, to whom is universally accorded that honor. Spherical astronomy had its origin with the Alexandrian school, many famous geometers, and in particular Euclid, pointing the way. Spherics saw the doctrine of the sphere was the subject of numerous treatises, and the foundations were securely laid for that department of astronomical research, which was absolutely essential to further advance. The artisans of that day began to build rude mechanical adaptations of the geometric conceptions as concrete constructions in wood and metal, and it became the epoch of the origin of astrolabes and armillary spheres. And that's where I think I'm going to leave it. It's a little bit Eurocentric, but a very interesting read nonetheless. So if you'd like to pick up where we left off, you can, as always, find it on Project Gutenberg at the link in the show notes. Thanks again for joining me on this episode of Sleepytimetales, the podcast designed around a bedtime story to help you to get a restful night. New episodes will be released every Sunday night to give you something fresh to help you rest in a new week. But make sure to subscribe on whatever service you use so that you get your new episodes whenever they come out. A reminder that the music for tonight is Sweet Night and Friends by Kumiku. Check out more of their work on their website, which you'll find linked in the show notes. Good night, and sweet dreams.